I have opened a PDF. Oh, it just takes me to this site. Okay, why not? Alright. Yeah, I was thinking maybe I could see, let's see. Okay, why not? No, wait, no. Actually, no, I'm not doing that. I feel like I wouldn't be able to focus as well. You can put your own music over this if you want. Okay, so, let's see. I don't have an option for black pen, so I guess I'm on red pen. I could switch. I could do a red pen, blue pen here. Ooh. Okay, so first question. Is this foundation? No, no, this is a genuine question. Okay, well, it would be really funny if after that I got it wrong. So a way that a lot of people work this out is what we can do is we can do 6, and this is the way I normally use when I'm like in an exam. I do it like this, although I could probably do it mental maths or by another method. I think in an exam I do it this way. So what you do is, sorry if I'm teaching you an extra method, you can just kind of, why is it struggling to process this? It's not very, why is half the time it's just not, it's not that hard. You don't need to save every single annotation. Oh my god. Is there an easy, is there like just a line one? No? Okay, we're doing this. Okay. So let's say we're going to use 6.3, okay? You don't need to circle it on the test. I can just tell if we start doing the other one. So times 2 times 4. And what we're actually going to do is, for the 2 we're going to put a 0 here. And then we're going to do 3 times 2, which is 6. And 6 times 2, which is 12. So 1260. I'm going nice and slow for you guys. Right. 3 times 4 is 12. 6 times 4 is 24. And then plus the 1 is 25. This is going to be an easy 3 marks compared to some of the other questions on here. Yeah, I think that's right. I was just checking my working. Very important stuff. Then you add them at the end. So that is a 2, not a 1. That I can't edit that very well, but that is a 2. 11. And then that is 2 plus 2 plus 1 is 5, and then 1. Okay, so this would be 1,000. This would be 1,512, but we've got the decimal points, and because we've got 2 decimal points that are multiplying, we actually, I'm pretty sure, yeah, we put it here. We put it here because there's 2 decimal points. So our final answer is 15.12. Right? It won't let me decimal point. Oh, there we go. And I actually mentally double checked just now, Because if we just do it normally, 6 times 2 is 12, right? So we already know we're roughly right if we just look at it from that, because 6 times 0.4 is 24, so 12 plus 2 is 14, and we can see that it's already really close to 15, right? So it must be right. Okay, this one is 1. Anything to the power of 0 is 1. This one... Oh, sometimes I get these ones mixed up, but I think I know this one. So this would be 5 over 5... No, it would be 1 over 5 squared, right? And 5 squared is 25. So this is 1 over 20... There we go. 1 over 25. So, right, 2 to the power of 5 times 2 to the power of 4 over 2 to the power of 3. So, this is... To be honest, I don't think you have to write out your working for this one. There's not very much working to do. Actually, to be honest, if you just... Okay, so what you do here is you add the powers and then might subtract them. So 5 plus 4, 9. So, and then to get the working mark, I'd probably do something like that. To be honest, I don't know if you need to show your working, but it's 2 marks, so it's best to do that anyway. And then we do 9 minus 3 is 6, so it's 2 to the power of 6. And for anyone wondering, I can't confirm these are the right answers, but we're going to check over them at the end anyway, right? So watch till the end. That is meant to be a 2. Right, 156 is a product of its prime factors. Okay, so if it's even, often a good starting point for this is to divide it into 2. For 156 though, I feel like I might know something else that might be faster. Isn't it like 8? I feel like it's a multiple of 8. I'm not sure. So we're just going to do the 2 method. So 150 divided by 2 is 75, and then 6 divided by 2 is 3. So that would be 75 plus 3, which is 78, and 2. I guess we'll find out if I was right. So then we can, this is even still, so we can divide it by 2 again. 78 divided by 2 is 35 plus 4, which is then 39, because the 8's divided by 2 as well, so that's for the 4. Ah, so I can't have been right. It can't have been a multiple of 8, it's only a multiple of 4, because I think 39 is not a prime number, but it's not an even number either, so I can't have been right. Okay, so then 39 divided by 3 is 3, and is that 13? Yeah. So there we go. Now, as a product of its prime factors means that you just basically lay it out like you would when you simplify it in algebra. So, so you lay it out. You lay out the prime numbers like x and y, for example. So 2. So what we do is 2 squared, because there's 2 times 2, right? And then times 3 times 13. Okay, I need water, so I'm just gonna pause this here. Can I pause my recording? I can. Oh, that is such a massive time save. Okay, I'll be right back. And I'm back, and it's probably to you like no time has passed, because the pause button that I never knew was there is absolutely awesome. Okay, so now we need to find the highest common factor of both of these. So normally there's a weird method that they teach you with Venn diagrams and stuff, but to be honest, I don't think that's really necessary. Just because I didn't really like, I didn't like that method. I just think it's unnecessary, and if you know how to do it easier, it's so much faster. So I'm just going to do this the way that I know how to do it, to be honest. If you do it a different way, my bad, I guess. I can't do it. I can't do every method. But it doesn't matter. So, and then that goes into 5 and 12. However, 12 also goes down into 3 and 4. I'm not going to keep drawing these lines because it keeps, I have a cooldown for it for some reason. And then 4 then goes into 2 and 2. Actually, the most common, I think one of the most common mistakes I saw when I went over my exams was that I wrote down 4 as a prime number because I just forgot to simplify it, because it's one of those small numbers that feels like it doesn't simplify, but it does. So because I think it's used a lot in maths is why, like similar to 2 and 3, you know. So that's 2 cubed, not just squared, because there's another one there, and then times 3 times 5. So now what we do is we think. So I think that something they sometimes miss out in maths is what the actual point of what you're doing is, and I think that's a very, very useful thing to know. So they just teach you like this method. I think often they just teach you a method which works, and it's simple to understand, but it's not properly showing you the maths that's going on here. Okay, so HCF is the highest common factor. Oh, it literally says that, my bad. But a factor of a number is it's like one of the things you multiply together to get to it, right? Like 130, 65 and 2 are factors, right? So when we need to find the highest factor of these two numbers, we need to find a number. We need to find the biggest number that's inside both of these numbers, essentially, right? So 2 squared times 3 times 13, and 2 cubed times 3 times 5. Well, 2 squared is in both of them, right? Because although this one's 2 cubed, that's just an extra 2. So it's still 2. It's still 2 squared times 2, right? So 2 squared is in both of them. So we could, so that gets us 4. But then 3 is also in both of them. So we do 4 times 3, which is 12. So 12 is the highest common factor. If you know your 12 times table quite well, then you can actually just do that, probably. Because you could be like, oh, 12's a pretty big number. Like if you are ever short on time for a question like this, and you're like, oh, 12 goes into both of these, then I think what you'd want to double check is if there was a multiple of 12 could be higher, like 24 or 36, so you'd want to just double check that that's not in it. But to be honest, I think if you did know your 12 times table for whatever reason, you'd do pretty well at this. I used to have a board in my house, like a big poster up that had all the times tables in it, but instead of stopping at 10 for some reason, it stopped at 12, so I learned the 11 and 12's times table, and I just haven't really forgotten it. Except not for this question, because it didn't go up to that number. The mean length of 5 sticks is... I hate these ones. Okay, but I think we can do this. The mean length of 5 sticks is 4.2 centimeters, right? So immediately what I'm going to do is I'm going to write this out in algebra. So what's going on here is there are 4 other sticks that we're multiplying together. We don't know their exact value. So we'll call the number, wait, hang on, the mean of the other 4 sticks. Wait, what? Oh, right, yeah. So we want, so what we have here is we have the length of one of the sticks, an individual stick. So let's call that O for 1, just because we can remember that, right? So actually that might be a bit confusing. Let's call it S for stick, right? And then the other one is the mean length of the other 4 sticks. So it's a group of sticks, so we could call that P for pile, right? So S, so the way that this works is it's 5 sticks is 4.2, right? So the mean of S and P is 4.2. Full stop isn't working. Oh, there we go. And S, and to calculate the mean, you divide it by how many there are. Now, there are 4 different sticks in P, while S is just one individual stick that's 7 centimeters. P, we don't know the number of the length of the individual sticks in P. P is just an average. It's the mean length of the other 4 sticks, right? So S times P. Oh wait, no. S times 4P. Because it's the mean, we need to multiply it by 4 to get to the total length of all the sticks. Over, what would it be? It would be over 5, right? Because there's 5 sticks. Equals 4.2. So now that we have this equation, we can just work it out from here, right? So if you know how to simplify equations and stuff, so like, we just need to find P. So we can go down it like this, 5 times 4P, and then, wait, no, actually, we don't even need to do that, right? Because if you can see here, look, we'd be doing, because this is divided by 5, we need to times the other side by 5, right? But then this is also times by 5, so we need to divide this by 5. So from that, those two kind of cancel out, because we're multiplying this by 5 and then we're dividing it by 5, right? So times by 5 is 5 times 4p, then divided that by 5 is just 4p, right? So times by 5 divided by 5 is also the same number. So this means that we can cancel out the 5s, and 4.2 equals 4p. So we now need to divide this by 4, right? So because we're dividing this by 4, we also need to divide this by 4, because this is 4p, it's too many. So if we just go to 1p is equal to, and I'm going to write this in the answer box because it's also the answer, 1.0, oh, that's not really clear as decimal point, 1.05. There we go. Nawal made a mistake. The stick was not 7 centimeters long. It was 17 centimeters long. How does this affect your answer to part A? Okay, this is a 1-mark question. So, to be honest, I don't know if they want me to answer what the change is, or if they want me to say, oh, it gets bigger, or oh, it gets smaller. So if we just look at it, wait, oh my god, I'm an idiot. Wait, no, this isn't the right answer. Wait, this is why you always check your working, right? This is why you always check your working. Because I've just noticed, I misread this as 5. It's not 5, it's S. S was the length of one of the sticks, and that is equal to 7. So if you saw that mistake, great job. You're better at maths than me. Uh, so we can. I need to just undo a couple of steps. Let me go back. Hurry up. Hurry up. Okay. Yeah, so that is actually 7. We shouldn't really have... It's difficult to write it out on here. So I'm sure I would have noticed that's an S and not a 5. But yeah, so it's actually 7 times 4p, which means it would be 28p over 5. So 28p equals 21, right? And then this is kind of weird. So I would say you use your calculator here, but you don't, because it's non-calculator. So you can't use your calculator here, and I'm not going to. So one thing we can notice is that's really useful is these numbers both appear on the 7 times table, right? These are both multiples of 7. So a good way of working this out is 21 is 3 times 7 and 28 is 4 times 7. So we can actually use that here and divide both sides by 7 for a start. So we get 4p equals 3. And then the great thing about this is we can leave p as a fraction because maths is fine with that. So equals, I might start writing equals as a z if that's not too confusing for anyone, just because I have a cooldown for every line I draw for some reason, so it's just much easier to do it this way. No, z looks too much like a variable. I can't do that. I can't do that. I don't want to be wrong. It could skew our calculations. It could mess everything up. So p equals, and then, so it's p divided by 4. P divided by 4 is p, so the other side would also be divided by 4. So it's p is 3/4. So actually, you can't leave it as a fraction here, because it actually starts as a decimal, so it's wiser to put 0.75 instead. Anyway, how could this idiot not notice that it's 10 whole centimeters longer? It's like more than double the length he thought it was. How did he measure this so awfully? Like, surely it would be so obvious on a ruler that it's not 7 centimeters. Did he have a wrong ruler? Like, I don't know. Okay, let's just go with it. We have to go with it in maths. So how does this affect your answer to part A? Right, so if that was 17 instead, then we would have a much bigger number. We'd have 280p. So it would actually divide it by 10. The final answer would be 0.075, right? Because it would be... Wait, no, what am I doing? 17 isn't 7 times 10. What am I on about? No, it would be 17 divided by 5. So that is roughly 3.5 times 7, although it's not. No, it's roughly 3 times 7, not 3.5 times 7. This is kind of hard without a calculator. we don't have to do this mental maths. Wait, no. So 17 times 4p, right? So the 7 gets times by 4, but that would also mean the 1 gets times by 4. So it would be 68p instead. Oh, I'm not actually going to edit that. 68p equals 21. Which means when we divided it by 7, we can't do that. So it would be... I think I'm thinking about this way too much for a 1 mark question. I'm just trying to get it right. I think... So if this was bigger, then it makes it smaller. So that means my answer was too large. We're just going to go with that for now. My answer... I'm going to make it all one word because the line cooldown. Too big. Okay, hopefully I can read that later. This is a fun one. So this is asking for the perpendicular bisector. So what you want to do is you want to get out your compass, and you're going to want to... Let me try and remember. Yeah, so you want to have it an equal length at both sides, I think. Yeah, and then you'd make this compass line. I know my lines aren't very straight because I'm using a mouse. And then you'd go down the middle of that, right? So it would look something like this in the end, because you just join up these 2 points, and that's a straight line, right? So I'd get all the marks on that if I had an actual pencil here. But anyway, we move on. Triangle shows an isosceles triangle ABD in the straight line ABC. BA equals BD. Right, yep. X to Y is 2 to 1. Work out the value of W. Okay, so the first thing we're going to do is just that we already know that X is double Y. So we're just going to replace that with saying 2Y instead. Right? So now we know how big this... We know all the angles in this thing, right? So if this is also 2y, then because it's an isosceles triangle, I would write that out as a sentence, but I can't really, because... Oh wait, I could write it out in text. Oh, I have the text feature, here we go. Because... I'm in the same font as the exam. Because the... isosceles triangle has one small angle. I mean, I don't really know how else to write this. Because of the angles in a... Yeah, normally this suffices actually. In an isosceles triangle rule. What? Okay, yeah. 180 is the amount of angles in a triangle. So 180. Maybe I should just write this all out in text actually. That might be much easier. Okay. 180 equals 5y, right? So that means that, yeah, this is so much easier. 36 equals y. and w plus y equals 180 because they're on a straight line. So then we can just write that w equals 180 minus 36, which I think you can just use mental maths for this bit, is 150 and then 144. By the way, no, never mind actually. I'll mention that at the end. It's not very important. It's not worthy of brain space. I'll just write it down in my notes actually. Wait, I can pause. I just remembered. Yeah, that's a note I probably would have remembered anyway, to be honest. But it's good to write some of these things down. Okay, so on to this question. I can edit the PDF. I'm not doing that. I mean, I can edit what the PDF is written, but I'm not doing that. Okay, so Mano has 3 shelves of books. There are X books on shelf A, there are 3x plus 1 books on shelf B, and there are 2x minus 5 books on shelf C. So one thing to note here quickly is that it's measuring the amount of books, right? And we cannot have 0.5 of a book. So that's just something I would make a mental note of. But it's not actually asking for that, so that doesn't really help. I've just noticed it's finding the mass, not the amount of books. There is a total of 44 books on the 3 shelves, so it just tells us immediately, it doesn't matter. All the books have the same mass. The books on shelf B have a total mass of 7,500 grams. Work out the total mass of the books on shelf A. Right. So there are 3. So the total amount of. Wait, no, we already know the total amount, folks. No, wait. The total amount of books as an algebraic expression, we just add these up. I don't know why they're in brackets. That doesn't really. I think it's just because they wanted to look more mathsy, or maybe they want to separate out. I don't know. Doesn't matter. But so we can add these together like terms. So 3x plus 3x plus 2x is 6x, and then plus 1 minus 5 is minus 4. So 6x minus 4 equals 44. So then, by the way, I'm not actually going to be checking the working marks later. That was actually the thing I made a note of. So, so I'm not going to bother making working notes from now, really, if it's just really fast to do it this way. So 6x equals 48, which means x equals, just because I don't really have time and I'm not very good at reading the mark schemes working, I'll have it on screen so you can check it if you want. X equals, that is 48 divided by 6. This is always a weird one. 8. I always forget what that one is. It's always like 42 and 48. They're just the most irrelevant things when it comes, like 6 times 7, 6 times 8. No one knows those. I used to have a thing with 7 times 8 actually, and I just could never remember what it was. I'm going pretty off topic here. So I can't get distracted. I'm not allowing that. So now we know x equals 8, right? And there are 8 books on shelf A, 25 books on shelf B. The books on shelf B have a total mass of 7,500 grams, right? So since there are 25 books there, we can figure out that all the books have a mass of 300 grams, right? So that means if there are 8 books on shelf A, then it's 8 times 300, which is 2,400, right? There we go. Oh yeah, that's it. Okay. That was not hard at all. Wow. I thought it would be a bit harder. Maybe it's just because I just getting started. Okay. The normal price for mattress is reduced by 40% in a sale. Price of the mattress in the sale, right? Okay. So, okay. So since it's been reduced by 40%, 660 is 60%, right? So we can't just multiply it by 0.4 to get it back because that's not how that works. For example, I'm just gonna. This is something I get confused about sometimes, so I'm just gonna show you quickly why that doesn't work. So if you so what is a good example of this? 50% of 100 is 50, right? And then, but then you can't just times it by 1.5 because 50 times 1.5 is actually 75, not 100. So this one's been reduced by 40%, right? So the best way to do it is to work backwards. 100 minus 40% is 60, right? So we need to get from 60 to 100. How would we multiply that? So at this point, I'm not really sure what the answer to my own question is. So let's go back to the example with 50%, and I'll just quickly see if I can do that. So 50 times 1.5 isn't right. Shut up. In real life, this wouldn't be a question worth putting this much effort into if you didn't know. But to be honest, I probably would. If I thought about it this long, and since it's only 2 marks, I would have just left it by now. Who is sending those? I don't know. I'm just hearing the sound effect. I have no idea what that message is about. So, so for this, what we're missing, so if we're going to 60%, we're missing 40%, and you can divide 60 by 3 to get to 20%, and then just add that twice. Okay, so what I do, because I'm sure there's a normal method of multiplying it by something, but I can't think of what that is at this current moment in time. I don't know, but what I'm gonna do here is I'm gonna take 660 because it's conveniently close to 60, and if we divide it by 3, then we just get 220, and then it must be 660 plus 220s, so 660 plus 440, which is 1,100. 1100, I think. Yeah, I think that's right. There we go. To cook rice. Something I still have not yet managed to achieve. The number of cups of rice is ratioed. I don't know what else to call it. Proportionate is proportionate. Number of cups of rice x to the number of cups of water y is 4 to 5. Okay, yeah, I think that's how you say it. So use this information to draw a graph to show the difference between the number of cups of rice and the number of cups of water needed to cook rice. Okay, so I think the best way to do this is we start off with 4 and 5, right? So x is 4, y is 5 in this ratio, so we just go, oh, this is cups of water though. They've tried to trick us here. So this 5 would actually go here, because this is cups of water column. And then 5 and 4. Okay, so what we can then do is we can just double it and go to 10, 8. And just draw a straight line back like this. There we go. My line is not very straight. Find the gradient. Okay, so it's... This always helps me actually. Sometimes I think that the euphemisms are kind of annoying that they use in maths, and I don't think it's good a euphemism, but you know, like the oh, you'll remember it if you think of this, right? But one thing that I always remember for this is that it's rise over run, right? So if it's risen by 5 here, and run is like the distance, like think of water running over something, or just a person running over something. That makes more sense. So it's ran 4 and it's risen 5, right? So that means that it'll be 5 over 4 because it's rise over run. And we can probably just write 5 over 4 as the gradient, I think. 5 over 4. But if you wanted, for whatever reason, if something in the question implied you needed it as a fraction, it would be 1.25, because 1 over 4 is 0.25, so since it's just 1 1/4, it would be that. Explain what this... Why am I going down? Okay. Explain what this gradient represents. Ooh, that is a mean 1 marker. I would probably just come back to that at the end, if I'm honest. But what does it represent? It's actually quite simple, I think. Yeah, so when this goes up, what I'm noticing here is when this goes up by 1, this could just be because I've not drawn the line very well. Wait, let me try and get some variations here. Yeah. So I can't really rely on my graph at all. So 5 over 4, what does that actually mean? Well, when it goes up 5, it goes along 4, right? So that means that when this is divided by 4, this goes along by 1 and it goes up by 1.25, right? So that means for every cup of rice, you need 1.25 cups of water. So it represents the amount of cups of water you need for cups of rice. There is a lot of water required in this. I know because I haven't actually done it yet. I've got enough stuff to make sushi at the moment, and I'm hoping to do that at some point. But I've seen my nan's made it before a couple of times, normally with me. But when she makes the rice, there is so much water involved. So the like a lot of water. Circumference of a circle is 10 meters. Work out the area of the circle. Give your answer in terms of pi. Okay, so in my opinion, this is quite a nice, easy one. So the formula for area is... Oh, I know this. I don't know why I can't think of it at the moment. It will come to me in a second. Pi r squared. Yeah, of course. So pi r squared. This means that because you multiply by pi and then r squared, first we need to figure out what r squared is in 10. So we need to do the square root of 10. What is this? So it's the square root of 10, which I'll just write like this. and then we're gonna have it. Wait, so is there an obvious square root of 10? No. Okay, so we don't really know what that is. Not off the top of my head, I don't know. I don't think anything squared is 10, really. Like 3 squared is 9, so it'll be some random number. So instead we're going to leave it as a surd, square root of 10, and we're going to just put that over pi, because it's r squared times pi. So yeah, this is a really easy one, I think. I'll just write it as pi. So square root of 10 over pi. That's literally it. Okay. And if you did want, another way of writing this, if you wanted, is no, there's not really. So sometimes you can move pi to the, you can make it a mixed number and then remove pi. Sometimes they like that more, but no, you can't really do it because pi is the denominator. So no, you can't do that. You can't really simplify that any further. Alice recorded the number of cars going into a village on each of 80 days. The incomplete table and the incomplete box plot give information about her results. This takes a lot of water, just like rice. Use the information in the table to complete the box plot. Use the information in the box plot to complete the table. Okay. So, basically, this box plot has some values that this doesn't have, and this has some values that this doesn't have. And so the lowest number on a box plot is represented, you just kind of have to know this, is represented by a line at the back. Oh no, that is I've got a text box on still. Here we go. Oh no, that's at 400, not 300. There we go. It's just a line, and then that is how you show the lowest number. Then we've got the lower quartile on here. The median is 900, which is represented like this. And then that's not the highest number. That is the range. They've tried to throw us off here. So we need to complete the box plot. So we do need the highest number. The range is the highest number minus the lowest number. So the highest number must be 1,300, which is here. These maths people are being really mean. Okay, let's just fill in the rest of this. So this on the graph is here, which is of course just slightly off center. So yeah, it's since this is 700, I think this is measured in 20s, so it would be 780. And then the upper quartile is that one, and that is just bang on 1,200. I can't quite, that's not really in the right place. There we go, that works for me. Okay, so now both the graphs are complete. On some of these 80 days, Alice saw fewer than 1,200 cars going to the village. Work out an estimate for the number of days Alice saw fewer than 1,200 cars going into the village. Okay, so instead of finding an actual number of days, we're gonna look for the percentage first, I think. So this obviously is 50%, right? And since this is the upper quartile is between the highest number and the median, so that's then 75%, right? So 75% of 80 is the answer, because the upper quartile is 1,200, this is 1,200, and we're looking for less than, which is 75% of this graph. So 75% of 80. What you can do with that is you can divide it by 4 and times it by 3, which will get you 20, then 60. So that's 60. We're absolutely destroying this paper so far. I can't think of a mark I've lost so far. I mean, this is how I normally feel on the tests, though, so there might be something I've gotten wrong, you know? Either that or I'm just a god at maths. I'm beginning to feel like a math god, math god. All my people from the front to the back nod, back nod. The straight line L has equation. It's L from Death Note. Sorry, I've been watching that recently. The straight line, it's really good, by the way, you should watch it. The straight line L has equation 2y equals 3x minus 7. I'm sorry, I've just thought of this for some reason. I just wanted to say, because we brought up Death Note, I think Death Note is one of those shows where, you know how you have stuff like Frankenstein and Shakespeare and Animal Farm that we have to do in English? In the future with media, I think that Death Note, because it's got a lot of symbolism in it, might be like one of those things for like media studies. I feel like in the future it's probably going to be a big thing on media GCSE, or I don't do media, but I think it's a GCSE in some places, so you know. Thought I'd mention that, don't know why. The straight line L has equation 2y equals 3x minus 7. Right, so by the way, obviously I wouldn't think for very long about Death Note on the actual GCSEs, because I'd be like, oh my god, I'm not thinking about Death Note. I'm thinking about the answer to question 12. I need to lock in. I'm not letting my ADHD destroy my GCSEs. This is why I get extra time, but because I can focus, I can still do pretty well anyway. So, find an equation of the straight line perpendicular to L that passes through 6 minus 5. So, first things first, 2y equals 3x minus 7 is equal to... First off, y equals 1.5x minus 3.5. Okay? Wait, actually it's going to be much more useful if I lay it out as a fraction. So y equals 3.5 equals 3 over 2x minus 7 over 2x. Okay, I'm going to have to pause it right there. Alright, I'm back. So, yeah. Sorry, let me just get my maths brain back on real quick. Yeah, so we needed to find the straight line perpendicular to L. So what we do here is the negative reciprocal gradient is the first thing we do. So the gradient here is 3 over 2, and the reciprocal would be to flip it to 2 over 3, right? Now by making it negative, we do that. So this is what we've got, the gradient, so let me think, y equals mx plus c, so m equals minus 2/3, right? Then, now the reason I'm just going to put y there for simplicity, because we don't need to worry about this, because it doesn't need to connect with L, it needs to pass through this specific point here. So what we need to think about is if if so x and y, if x is 6, then y needs to be -5, okay? So 2/3 of 6 is 4, so then it's -4, right? Y needs to be -5, so we need to subtract an extra 1. So that means it must be y equals -2/3 of x minus 1 to get it to -5, because then it passes through that point, because when x is 6, this bit is -4, and then -1 makes it -5 at that point. So there we go. Oh, error. Okay, I'll just write the answer on there again. I don't know why that's gone wrong. So it was what? Why? What? Yeah, still let me do that. Okay. Okay, so yeah, okay, here we go. We've got a text box at least. So y equals -2/3 x minus 1. There we go. I don't know what the working was. So solid A and solid B are similar. Oh, it's going to be one of these. Okay, the scale factors. The ratio of the height of solid A to the height of solid B is 2 to 5. The volume okay, yeah. So length's scale factor is the scale factor that lengths change at, right? And our volume scale factor is a cubed version, because we've got centimeter cubed because there's 3 different axes, 3 dimensions. That's it, 3 dimensions. So a one-dimensional line, we start off like this, 2 to 5, right? Now 2.5 times 2 equals 5, so the scale factor from A to B is 2.5, right? So 2.5, so a good way to lay it out is LSF, because that's clearly the length scale factor, equals 2.5. So VSF equals 2.5 cubed. Okay, since we're on, well, that's not great, because that is quite hard for non-calculator. But so if I just put in maximum brain power, right, engage brain a bit here, so it would be 5 point, then okay, now what I'm gonna do is, I think the best way to lay this one out is 2.5. So we do first. We're gonna do 2.5 times 2.5, right? So 2.5 times 2.5. 2.5 times 2 is 5, right? And then 2.5 times 5, but we're gonna put it 1 digit down. 2.5 times 5 equals 10. So that'll be a 1 there and a 0 there. 10 and then 25. So 1.25. I actually found that a little tricky. In the actual test, I would be all warmed up. I wouldn't have just come back on like question 12 after watching The Apprentice. I would be prepared, so I'd probably have done that a lot quicker. 6.25 is, but that's the aerial scale factor, because I've only squared it. I need to now cube it by multiplying it by 2.5 again. Okay, so 2.5 times 6, well, if 2 times it's 5, then 5 times 2 is 15, so that'll be 15. You know what, I'll add in the decimal points later. Wait, no, it's three decimal points. Nah, okay. So if it's let me think. So 2.5 times 6, yeah, definitely 15. And then I think that since that's the first digit here, yeah, it would be 15 point, right? Now, then we do 2 times 2.5, which is 5. And then 5 times 2.5, which is what I struggled with on the last one a little bit. But I think it was 10.5? No, 1.25. Yeah, it was 1.25. Wait, but how could that work? Can it be 1.25? Maybe. Let's just do it again. So, oh wait, no, this is slightly different, isn't it? Because it's 2.5 times 0.05. That's actually not that different. Wait, no. So 2.5, 5 times 2 is 10, and then 0.5 times 5 is 25. So it would be 12.5, right? Yeah, okay. Okay. Sorry, for some reason this is just messing with me a bit. I don't know why. It's just this specific calculation. It's just annoying. So I think, if I'm right in thinking, since it's 0.125, it should be 15.65, I think. Yeah, I don't really know why we have to work that out. It seems a bit over the top. Have I done something wrong here? No, that's definitely the ratio of the heights. And it doesn't say they're a cube. Yeah, no, you just have to multiply it by this. I don't really... Could I have done it as a fraction? Ah, right. I think maybe you were meant to do it as a fraction. Okay, that makes sense. So if I did it as a fraction instead, 2.5 is 5 divided by 2, so that would be 5 over 2. I'm just gonna... Actually, I might finish doing it this way and then try doing it the fraction method. And okay, so I'm gonna do 2 different ones. I'm just gonna put 5 over 2 there, so I remember to do that one as well. Okay, so for some reason I can't go to that lower bit. Oh, there we go. So then we do 12 times 15.625, and it doesn't say to round it for some reason. So we just go with that, I guess. This is the decimal method is probably the harder method, I'm guessing, if I'm right in thinking that it's meant to be fractiony, but we'll do it anyway. So that's 12, and then I know my 12 times table, as I said earlier, so this should be quite easy. Then that's okay. So the last two digits kind of got cancelled out, so it is seeming more reasonable now. This is a pretty reasonable answer, so I feel like we were probably meant to do that as a fraction. Let's just check. So 5/2 cubed. Sorry, that was William, but I used my magical pausing ability. So yeah, if we were to so how do you square a fraction? That's always kind of weird. So well, we now know that it was 6.25. So let me think. 6.25 is okay. What I'm actually going to do is I'm going to work off of this to find 5/2 squared, and then that should help me tell you the method, right? So I'm going to use the wrong method here just because I don't know what the right one is to figure out what the right one is. So 6.25, that is 12.5/2. So 12.5/2 is then over 4, 25/4. So what's actually happened here is we've squared the top and we've squared the bottom, as you can see. So that must be the method. So I think that we're meant to cube the top to get 100. Oh wait, no, I'll leave this here. And then 125 over. No, that's not right. 8. There we go. Okay, yeah. So then it would be 12 times 125 over 8. First you do 12 times 125, which is 12, then 24, then 60 again, which is kind of how we left the last one actually. So then that's and then that's over 8, and then that definitely looks like something that can be simplified, so let's simplify it. 500, 750 over 4, and then that can be further simplified. 375 over 2, and then that can't really be simplified, but it makes sense. I think it is this. If you can just look at it and tell that it's kind of this, right? So we've got these two different answers. I'm curious to see whether they put it in the fraction form or the decimal form. I guess we'll find out, but we've come to two different answers. Just separating out the answers to make it more clear. Alright, work out the value of 7 to the power of 2/3 plus 1/2 to the power of -3. Okay, So first we need to figure out what both of these are. Why is the scroller so big? Okay, I have no idea why that's like. Oh, it must be because I grew it out. That's kind of annoying, but we'll go with it. So 2/3. I think that means that we put it in a square root, where it's like the square root of 3 squared, if that made any sense. Root 3 squared. So no, what I mean is we take 27 and we like square root it to the 3, so we cube root it, and that gives us 3, right? Because 3 cubed is 27, so we're just doing that backwards. And then we use the what's this called? I know the bottom one's the numerator. The numerator is 2, and we square it by the numerator, which gives us 9. So it's 9 plus whatever. What have I? Wait, have I accidentally? Oh, yeah, I must have pressed control by accident. No, it just works with shift. Shift. I don't know why it does that. Okay. I guess Google does not want me to use the plus sign. But anyway, yeah, so it's 9 plus then 1/2 to the -3. So if I think I'm right in thinking that sounded odd, but doesn't that make it like 1/2 and then over something squared? Is that what it means? Wait, let me think. Yeah, no. So I think it might be the reciprocal actually. Wait, so 5 to the -2 is 1/25. Yeah, I think it must be. It must be the reciprocal. As far as I know, I might have got that wrong, but we'll find out at the end, I guess. So that would be 8/1, which is just 8, and then that's 17. Not aggressive at all. Okay. An object falls from rest, right? So it starts at 0 speed. Here's the distance time graph for the distance, d meters, fallen by object t seconds after it starts to fall. Work out an estimate for the gradient of the graph at t = 3. Okay. So I can't really get the answer to this, but I can show you how you would, I think. I think we did this at school. To be honest, I wasn't really, I didn't really know what question we were solving, so I didn't really know what was going on, I'm not gonna lie. But I think what you'd do is you get up a ruler, right? And you just go like, I'm sorry. Pretend that's on that point. I can't undo it for some reason. Oh no, I can. Okay, I'll just go from both sides to make it clear, right? So we want it at t = 3. So t is time. So we go out like that. And then we go out like that. That's roughly right. And then we do the rise over run of this to get the gradient. We basically turn the curve into a line for 0.3, and then we can figure out the gradient of that line, right? Because this is a curve, but at that point, if we zoom in by infinity, okay, hopefully this isn't overcomplicating it, but curves are made out of tiny lines, right? So what we're doing is we're figuring out the gradient of that line at exactly this point here, when t = 3 on the line, right? So we're making the tiny line that is technically there bigger by drawing this out. And I can't really estimate. I mean, can I estimate? Wait, I've got a bit of an idea. So I can kind of look at this and try and figure out where the line would go. Because I want to try and get as many marks on this as possible, so I can be like, oh, would I actually have gotten the mark? And if this one can't really be a middle ground. So if we just, so it's when t equals 3, right? Yeah, so it's this point exactly right here. If you drew out a line, I think it would be go there. Maybe a bit above that actually. And then maybe up to that. Alright, so this is a bit of a guess. But we do the rise over run for this. So that's 25, that's what is this measured in? Oh yeah, it's 5. So this is 20, 15, and that then goes up to, I guess that is the magic of the pause button. You don't hear mum randomly coming in now because I can just pause it in the exact moment. But yeah, rise over run. So this is 15, and then this is 65. So the rise is the amount it's risen, obviously. So it's gone up by 50, which sounds like a nice round number. So it does sound a bit like what they'd have in the test. And then the t is increased by 2. So it would be 50 over 2, which is 25. Gradient is 25. I mean, if I'm even close to being right, then I'll probably count it, to be honest, just because this is, I couldn't really draw this at all. Actually, this all looks like it should be shifted 1 up, but that makes it seem more accurate now, because that would be the same gradient anyway, so you know. At the start of year n, the population of a species is Pn. For some reason I immediately thought aliens when looking at that. At the start of the following year, the population of the species is given by Pn+1 equals Kpn, where K is a positive constant. The population of the species at the start of the year is at the start of year 1 is 8 million. The population of the species at the start of year 2 is 6 million. Work out the population of the species at the start of year 3. Right, okay. So immediately what we can notice is it's going down, right? So that means K must be less than 1. So what this is saying is P1, N is the year, right? So P1 is year 1, it's the first year. P2 is year 2. So it's just like, instead of using X and Y, there are different variations of P, because P is sometimes year 1, sometimes year 2, sometimes year 3. Instead of trying to come up with symbols for all of them and representing them like Y, X, and 5. No, actually 5 makes no sense. Like Y, X, and for some reason I keep wanting to say a number, like C for year 1, year 2, and year 3. P1, P2, and P3 just makes more sense, right? Because I feel like a lot of people will be thrown off by the way that this question looks. And a positive constant just means that it's a positive number. Constant means it's not changing. So, but that should be fairly obvious, since it's not like Kn or anything. Right. So work out the population of the species at the start of year 3. So the first thing we want to figure out is, what is K? Why is it so big? I don't want to... Why is the cursor this big? Why is the text I'm trying to shrink it. It's not shrinking. I'm just gonna... I don't care. I'm gonna make the text smaller. Is the font size really big or something? What? Okay, let's go with this. So year one, it's at the start of year n, and then n plus 1. Wait, so I'm assuming year one is the first year, right? Because it doesn't actually say when it says... Oh no, yeah, this is kind of a sequence. So year one would be the first number. So does that mean that it's already... K has already been applied? It doesn't actually matter, actually. No, never mind. So 8. So the equation we want is just straight up 8 equals K. No, 6 equals K8, right? So then from that we can figure out K equals, well, it's 6 over, oh wait. Alright, yeah, K equals 6 over 8. 6 over 8 is 3 over 4 is 0.75. But we'll go with 3 over 4 because fractions saved us before. So work out the population of the species at the start of year 3. Yeah, that would be really painful if it wasn't fractions. So at the start of year 3, P3 equals 3 over 4 times 6. Where's times? Wait, no, have I been using x before? It doesn't matter. 3 over 4 times 6. So then it's 18 over 4. I'm sure no one will mind if I've changed it from star to thing. 18 over 4, which is 9 over 2. Oh. Oh, I can't really undo that. B over 3 equals 6 times 3 over 4. And then that equals 18 over 4, which is 9 over 2, which is 4.5. So it's 4.5 million. Don't forget to say million. Actually, you can't forget to say million because it already says million. But don't forget anyway. Yeah, it annoys me because I'm always thinking, oh, what do I need? I need to put it in appropriate units and all that. But it already does that for you. You just need to do it, that kind of thing, in physics normally, or in economics, or in other subjects, not really maths. Is Louise correct? At the start of year 5, the value of k is increased by 0.3, so it will be 1.05. Louise is correct because 0.75 plus 0.3 equals 1.05 is greater than 1. Which will cause one. So for some reason I'm still thinking it's aliens instead of an animal. It's greater than 1, so the population would be increasing. I don't really like that answer though. I'm trying to think. What would a really good answer be? Equals 1.05. So population as it is. Okay, yeah, I think that's pretty good. I feel like that's hits all the key points. I don't think there's anything wrong about that. Okay, for some reason PDFs hate me, but never mind. We're gonna let them. We're gonna be like the hippies today. Peace, love, and plants, man. Factorize. 6x squared minus 5x minus 4. Ooh, it looks like it's time to bust out the AC methods. Yeah. So let me think. Yeah. So what we want to do with this is first we want to find 8 equals AC and then equals B. Yeah, we want to find two numbers that multiply to get AC and add to get B. You can remember that they multiply to... One sec. You can remember that they multiply to get AC because you have to multiply to get AC. So AC is a much bigger number anyway. So they always gonna have to multiply to get to that. While B they have to add to, because yeah, that's just the way it is. So AC is 6 times minus 4, negative 24. B is minus 5. So we need something. These two numbers need to be the same, by the way. They need to be a number that multiplies to get to this one and adds to get to this one. So, I mean, what you can do is list out all the multiples. Like Mr. Bruford actually showed us quite a neat mathsy table method. But to be honest, I find it easier to just think of them and try and figure out what they are. So let's see. So you get better at it over time. You can come up with strategies and stuff. Like one of mine, for example, was just now I was looking to see if the difference between any of them any of the multiples of 24 is minus 24 equals minus 5, right? That was just kind of an unconscious process, and I was thinking, since it's a negative number, I need to make the bigger number a negative, otherwise it can't be a negative when you're adding. So, but I don't know if you could follow along with what I'm saying. It's easier to pick up from practice than to tell you, I think, but I've tried to tell you anyway. If that helps. So it's 3 times minus 8 equals minus 24, and 3 plus minus 8 equals minus 5, right? So then you split up. So what you've basically found here is 3 and minus 8 are the two numbers in the middle. Instead of 5 is just those two added together, which is often done in maths to make it look simpler and stuff, you know, to simplify and all that. But what we've done is basically reverses that. So it would then be 6x squared minus plus 3x minus 8x minus 4. And then what we can do with that is we want to, now fortunately it's already like that for us, where you can see that these share multiples because there's 6 and 3, right? So can you see how 3 can kind of go into 6 because you can multiply by 2, and 4 times 2 is 8. So it doesn't always have to be times 2, but you've got to look for the ones where you think they'll have more factors in common, they'll have more common factors, and you want to put them next to each other. And if it doesn't work, then you just switch the combination. But the reason I'm saying about this is what you gotta do now is you gotta split these two up, right? And you've got to try and find the highest common factor of these ones. You need to. Is this simplification? No, yes, factorizing, sorry. You've got to factorize this bit, which is basically simplifying it. But so this one has x twice, this one has x once, so x is there. This one has 3 twice, no, this one has 3 once, this one has 3 once as factors, you know. So it's 3x. But then since this one had x twice and that didn't fit, often it's shown on a Venn diagram, but I'm gonna be real, it's too much diagram for me. X you just put there, but it's also 2x because this 2 isn't used because it's 2 times 3. We've only used the 3, so it's 2x, and then it's going to be plus. Shut up. Okay, I can't get that fast enough to turn that off. So we're just gonna have to deal with that, I guess. Is there anywhere else where there's a plus button on my keyboard? Oh yeah, there is actually. Oh. Hey, I didn't know that was there. No, so on my, I'm just gonna slightly explain my keyboard. There's not really any point. But you know how there's kind of a number pad on the far right when you have a computer? I've just noticed that since there's all the numbers there, there's also a plus there. So I can use that, and it won't trigger annoying thing. It won't make the screen, it won't zoom it in any further than I already have. Why was that so audible? I have no idea if you could hear that or not. I just took like a really big gulp of water. I don't know why it made that noise. It was so loud. But anyway, yeah, so that's literally plus 3x. So what we do here is it basically becomes 1 because 3x times 1 equals 3x. So 1 is kind of like a placeholder value here if you want. It's the most simplified you can make anything. So and most things you can't simplify down to 1, but the things that you can. Wait, is it? I don't know. It doesn't matter. It doesn't matter. That was just a way of phrasing it. You probably get what I mean. Okay, these are both negative. These both have 4. And so this one is 2x times 4. And this one is... Okay. Okay, I feel like a lot of people here would put -4, but it's actually +4 because... No, it's +1 because it's being multiplied by -4. You see, we have the same kind of thing going on, right? Now this bit's what we do now is you'll notice that these are both the same. This is because we've paired up the ones which have the similar terms, so we know that they'll be on the outside and they'll form the same thing on the inside. So this is actually one of the double brackets, because you know in a quadratic there are 2 brackets. This is one of the brackets, is what we found here. And oh, it's not going to let me do it, I don't think. Is it? No, it's not going to let me highlight them both. But these two, the 3x and -4, are the other two, right? Now the reason this works, I think, if you think about it, right, is that if you're if you've got these 2 brackets if you've got the double brackets next to each other, right? So I'm going to write them out now, how you would need to in the test. 3x -4, 2x plus 1. I forgot to thingy. Never mind. Is that you know how they multiply together when you want to expand them out like that? I think it's because 3x times 2x plus 1 and plus 4 times 2x plus 1. I think that's all the multiplication involved. Yeah, that's everything involved. So you would actually get the answer to the quadratic equation by doing that, and then adding them together. So that's the reason that works, I think. Yeah, if that makes sense. Yeah. But that's the reason you can find the double brackets from doing this, because you're looking at how you'd multiply them, and then you're just compacting it, if that makes sense. I'm probably saying if that makes sense so much that it's making you doubt if it makes sense, even if you understood it. So hence or otherwise, I never know why they do that. Why do they go hence or otherwise? Theo's mentioned this to me before. Oh, actually because when I first saw it, I thought they were like assuming you didn't know what hence meant. So they're going hence or otherwise, but they don't. It doesn't. Hence doesn't mean otherwise. It means based on this, or based on this. No. Therefore, wait. Hence is just a fancy way of saying therefore, like hence this, because of that, but what does or otherwise mean? Maybe it's because, I don't know why it says hence or otherwise. It's just one of the greatest mysteries in maths. Is an English problem. So, so this is the same equation. They do this kind of a lot, where they just put the same equation in a different scenario. So we need to solve this. So if we look at this, we can find out the solutions. That's that's the most important thing to figure out quickly now. So wait, no. So we're going to bring the brackets over here. 3x minus 4, 2x plus 1. Oh, I've done thing again. Sorry, I'm trying not to. But so how you'd solve this, if let's say it equaled 0, is what you do is, I think we're saying that this equals y, I think, right? So no, it's that it's equals 0. Yeah. So it's basically saying that either one of these two must be equal to 0, because then they'll multiply the other one to being 0, right? So if this said 0 times 2x plus 1, then it equals 0. Oh, I can't undo that for some reason. One sec. 3x minus 4. And if this one was 0, then it would make this this whole thing 0, because it's multiplying it by 0, right? Which makes it 0. It's like the black hole of maths. Yep. So 3x minus 4. So we need to. So we're trying to figure out two definitions, if you like, two values of x, because when we're looking for when this one's 0 and when this one's 0, right? The reason we're doing that is because, wait, I'm going to illustrate something real quick, right? The reason we're looking for the 2 points, what happens at the two different points where parts of these equal 0, the 2 points what we're looking for is the 2 points where y equals 0, because this equals 0. And it also equals y, because this is an equation that's like y equals 6x squared minus 5x minus 4, right? So if it's gonna, so when you have, oh my god, that's so awful, I'm gonna have to redo that now. If you have a line, whoa, that's a straight line, and then we have an equation, I think this is a positive curve, but correct me if I'm wrong in the comments. What we're actually finding here, this is kind of irrelevant to the question, but I feel like it's important for you to get it, just for maths in general, to be honest, because I think that maths, it's often watered down quite a lot, so you don't actually understand why you're learning it. So on an actual quadratic graph here, x is 0 twice. Similar to on here, where for this to equal 0, for y to equal 0, either this has to be true or this has to be true. Like either this equation has to be 0 or this equation has to be 0. And so this is this point, essentially, and this is this point, or the other way around. So I've basically given you so just by explaining in more detail what the point of this is, you could now intuitively, with no knowledge of like a method for it, then just figure out how to find these points on a graph. Just because I've explained this slightly better. That's what I feel like a lot of people are doing in maths. But so okay, let's get back to this now. X So, oh, I'm being bullied. Here we go. So x equals, so it needs to be multiplied by 3, so it's over 3, and why did that not appear? Here we go. So it's over 3, so it needs to be divided by 3, and then we want positive 4, so it would be 4 over 3, because if we think about it, 4 over 3 times 3 is then 4, and then 4 minus 4 equals 0. Then with the x, what we want to do is we want to end up at plus 1, right? So to do that, no, we want to end up at minus 1. So this must be minus a half, right? That's what we do when it's equals. On this one, it is less than 0. So it's going to be slightly different here, because instead of these points, I think that what we're figuring out is, wait, no, actually, instead of just explaining it, I think I'm just going to try and solve it instead for a second, and then I'll understand what I have better. So if this is smaller than 0, for this, wait, hang on. For this to be smaller than 0, these don't actually have to equal 0. But there are 2 points what we're looking for is for where x is a decimal. So for this one, we said, I can't bring it back now, but I can just do it again, is 4 over 3, right? That's what we said. So 4 over 3, that makes it all equal 0, right? But this is now like a maximum, right? No, is it a maximum? No. So so before we were figuring out this to equal 0, right? But now it must be below 0, right? How is this only 2 marks? Oh my god, this is offensive. So actually, I feel like I'm probably gonna get this question wrong, to be honest, but I'm gonna give it a go. This is still the maths mindset kind of thing. So for this has got it. So before this had to equal 0. Now it just has to be less than 0. But both of them have to be less than 0 at the same time, right? So okay. So I think that we would actually get one value from this. Hear me out, right? So x is the same number in both of these, right? Because it's x in one equation, right? And we're trying to find this times this is less than 0, right? So let's do it with a 1, for example. 3x minus 4, so we can just complete each bracket like x equals 1, 3 minus 4 equals minus 1, and 2 plus 1 equals 3. Then that's, wait, hang on, I just noticed me going on about a decimal earlier was pointless. No, it's not a decimal. What am I on about decimal? It's not less than 1, it's less than 0, okay? So it's not a decimal. I mean, it could be a negative decimal, but what the question is saying is that it's negative, right? So this means that x Okay, I'm starting to get it now. Okay, I get it. So they can't. So x. So this one is by default negative, if that makes sense, while this one is by default positive. What we need to figure out is the value of x that makes this negative or this negative, right? Because one of these needs to be negative for this whole thing to be less than 0, right? So let's just try and figure this out. So sorry for getting it wrong a couple times, but I think this is right now. So when this is 1, it's negative, right? So let's see, when this is 2, it equals 2, so it's positive, so we can't have that. When it equals 0, it's negative. So we're actually, so let me try and do some trial and error here. X equals 1 is a negative result, right? X equals 1 equals, what did it equal? -1, right? Yeah. Then x equals 2 made it a positive number, right? So now we need, let's try x equals 1.5. So 3 times 1.5. There might be a method to this, I don't know. I'm probably doing it the slow way, to be honest. I would just skip this and try and figure it out at the end, to be honest. Plus, it's getting a little late. I'm just kind of determined to finish this off now because I've started it, and I don't want to have to start another recording. So you know, it's a bit late. I'm a bit tired, but we're gonna try and get this anyway. So it's 3 times 1.5 is 3 plus 1.5, which is 4.5. If that made no sense to you, it's because 3 times 1 is 3, and 3 times 0.5 is 1.5, so it would just be also the same as 3 plus 1.5. So it's 4.5. Wait, what? Oh, no, yeah, -4 is 0.5. Okay, so I don't know about you, but I'm noticing a pattern here. I think. Am I noticing a pattern here? Yeah. When it's 0.5, it's 0.5 above. No, wait, no, the pattern doesn't work. Never mind. Okay, so let's just keep going. So it's 0.5. We need to get it to equal a negative number though, so it must be lower than 1.5. Let's try. So what about 1.3? 1.3 times 3 is 3.9. 3.9 minus 4. Ooh. Ooh. Ah, wait. Wait, I just kind of understood this. Okay. So this is minus 0.1. By doing this trial and error method, I've started to actually understand how you're probably meant to do this. So what we're meant to do has I think, been here all along. Remember earlier with 4 over 3, right? 4 over 3 is the answer. We just had to change the symbol slightly. And I was slightly confused over what way we needed to change the symbols, because I suspected we just needed to change the symbols, right? But now I get it. So when it's higher than 4 over 3, which is about 1.333, when it's higher than this, it's a positive number. When it's this or lower, it's a negative number, right? Because this makes it equal 0. So sorry if I got that later than needed, because I feel like some people would have got that before me. I answered this one quite slowly, to be honest, but yeah. So 4 over 3. That so since if it's higher, then it's no good. This must be the highest that x can be. So it's, will we say greater than or equal to? No, because it must be less than 0. So this must be less than this, because it must be less than 0. Now we're just going to do the same thing, because the other one was but I think this is the same. It's minus a half is greater than x. X minus 1/2 equals 0. Let me just double check that this is right. If it's higher than 1/2, then let's say 1, for example. Yeah, it's a positive number. Yeah, so yeah, this is right. Okay, so I've just figured out 2 lines. Probably took me, let me check the time on the recording. I think that took me like 10 minutes, maybe 20. That was probably a waste of time if you watched the whole thing, unless you didn't understand it, in which case you struggled with me. And we got through it, and hopefully you learned something. I think I have. For some reason it's not letting me. What the frick is it doing? Okay, I don't know why it's being so mean, but we're just gonna have to accept that it's being mean and type out the answer again in a weird font. So what was it? It was, yeah, 4 over 3 greater than x, or minus 1 over 2 greater than x, right? Yeah, okay. I'm happy with that. Okay, now to be honest, I think I'm just gonna mash these together on CapCut. I don't think I'm gonna continue tonight. I'm gonna finish this off tomorrow. Hello, I'm back. So because we got up to, I think, question 18, but now for some reason, like, all the stuff we've done so far has just deleted itself. I think I can roughly remember what we got though. It's in my head. So we're gonna quickly just see if the mark scheme lines up with that. So we're just gonna do this right now just to double check. Okay, so for the first one, I guess I'll be checking the method more than the answer, because I don't know the exact number. But 6.3 times 2.4 is 15.12. I think that's what we got. Yeah, I'm pretty sure that's what we got. so I'm just gonna assume we got that one right. I think we did. Yeah, 1 because it's to the power of 0, and then we got 1 over 25, which is equal to 1 over 25, then 2 to the power of 6. Did we get 2 to the power of 6? Yeah, okay, we did get that. Right, 156, the product of its prime factors. Didn't we get 2 squared times 3 times, was it 13 or? Yeah, I think it was 13. Yeah, 2 times 2 times 3 times 13, or 2 squared times 3 times 13. Yeah. So we got that one right. And then, oh yeah, and we need the common factors as well. Or was it? Yeah, find the HCF. Okay, do we have the HCF here? The HCF we got was 12, so. Oh, the answer was 26. What? We didn't get that, did we? Eh? 130. We must have. Right, so we divided it by 2. What did we get? Right, so we got 65, and that was apparently 13 times 5, so it should have just been 2 times 5 times 13 as the common factors. I don't know where we got that wrong, but it would just be 2 and 13 are the two that are common there. So yeah, I don't really know what we did wrong there. We might have done 10 times 3 or something for 13, I don't know. But yeah, the real right answer is 26, because these are the factors of 156. These are the factors of 130, right? And they both share a 2 and a 13. So 2 times 13 is 26. .5. Oh, question 4. Which question is this? It's this one. Right, yeah. Let me see if I can just remember this real quick. So, we basically had 4.2 equals 7 times x over 5. I think we used p though. Yeah, so I think it was 7 times p over 5. Was it 7 plus p? Yeah, no, it should be 7 plus p over 5. And then we divided that by, we times them both by 5. Right, and then we would have divided that by 7. No, wait. I don't know what we got. I think it might. Let's just check the method. So we formed an equation. We did this. 7 plus 4x over 5 equals 4.2. And then we went. Yeah. The total length of the 5 sticks is 21, and okay, I don't actually know if we got that one right, to be honest, but I think that it makes sense here. kinda. It reduced the mean. Okay, this makes sense, yeah. Yeah, let's just see for this one. So the answer was 3.5. So let's do this backwards. What they've got here is this. So if we do 3.5 times 4, no, okay, I don't know what we had before, but this is the answer apparently. I mean, if you want, you can go back and check if we got that right. If we got it wrong, the mark scheme is here, so you know. I don't know. Oh, I'm not in full screen. I just noticed. Angle construction. Yeah, we got that one right. We don't need the mark scheme. I'm pretty sure we got that one right. Answer 144. What was this question about? What I remember for this one, actually, if we just go back to this one quickly, I think that we did get 3.5 because I know that the answer ended in 0.5 because I was like, oh yeah, it's quite a clean answer, so it's probably is the right answer. Yeah, no, that was the bisector, and now we're on this one. Okay, so for this one, I think I got y, 2y, 2y equals 5y, then 180 divided by 5y equals 36. I might have thought it was 32 and it was 36. But no, it would have been 180 minus 36, which should have been, so that would be 144. Yes, so 144 should be that. I think it was. Who is Mano? What a weird name. Okay, Mano has 3 shelves of books, so maybe it's a very normal name that I've just never heard before. I remember this one. So we figured out that all the books weighed 300 grams. Then we did 300 times the amount of shelves on, so the amount of books on shelf A. What was X again? Wait, I'm just gonna add it up again. I don't know what X was. So it would have been 7x minus 4, I think. No, 6x minus 4. And that is... Right, that's 48 divided by 6, so it would have been 8. Right, x equals 8. I think. Oh wait, I've just scrolled down past it. Okay, so yeah, that seems right. I don't know if we got that, but it seems right. Yeah. So x was 8, then each book was 300 grams. So 8 times 300 was 2400. Right. Yep. The normal price of a mattress. Oh, I remember. I didn't get on with this one for some reason.
I think I remember the method that we were meant to use on this. So I think it would have been right. So what's happened here is it's been multiplied by 0.6, right? So to do the inverse, we're meant to divide by 6. That's what I didn't think of. No, not divide by 6, divide by 0.6, right? But what did we do? Oh, we added 40% back of it back on. So that would have been 440 plus 660 is 1100. Did we get that right? Oh, we did get it right. Okay. Kind of a goofy method, but we got it right. 9a graph. Oh yeah, we drew a line. I remember that. We did that. Oh. I think we got that. Yeah, okay. So it wants it in decimals for some reason, but I think it would have been fine with 5/4. Yeah. This is that. Oh yeah, and we've got a bang on answer. The number of cups of water per cup of rice. There we go. Yeah, and this one was 25/pi. Did we get that? Oh no, we got the square root of 10/5, didn't we? Wait. Oh, wait, no, this is the circumference. I know what we've done wrong. So, and we had to work out the area. So the circumference is 2, it's just 2r pi, right? So, it should have been basically 2 times 5/pi. So then what does that make the radius? Yeah, so 2 times 5/pi. That then makes the radius... Oh, I should probably be writing this out, actually. So the circumference is 10, right? So that means that 2 times 5/pi, that's the... so this is the radius, right? And now we want pi r squared. So I think how it would be... The frick is going on? Because we're multiplying it by pi again. So how is it over pi? Wait. Let's see what we did. Ah, okay. So the radius is 10/2 pi, or this one's the diameter, which is 10/pi. For using r equals 5/n, or r equals 10/2n. Or is this the full equation? Pi times 10/2n. So what we figured out before was that, wouldn't that be like 100 over 4n? Sorry, 4pi? Am I calling pi n now? 4pi? And then pi times that
Wouldn't that just be 10 over 4? Okay, I don't know what's going on with this one. I'm going to be real. Let's just skip that. Fully correct box plot. Well, I know my box plot's correct because I'm awesome. I think we got that? Yeah, 780, yeah. Yep, I'm pretty sure we got that, but let me just check the question. Yeah, we figured out it was 75%, so it was 60. Yep, okay. This is a real memory test. Because you've seen all this just now, but I did this yesterday. I had like 7 hours of sleep sandwiched in between this. So oh yeah, so we found the thing by doing the negative reciprocal and then minusing 1 because it didn't quite get to thing when it was thing. Yep, so that's right. Maybe this would be easier if... Oh, no, I didn't mean to do whatever that is. No, I don't want it as a group. Would this be easier if I could just... Yeah, okay, yeah. So... What? That is not what I wanted to do. So, does Control 1 just not work as tab 1? Is it Control Shift 1? No? Okay, no keyboard shortcuts are allowed now. What the frick is this? This is such a weird view. Since when has that been a thing? Okay, I guess we'll use this. Okay. What am I doing? I'm not even... I don't think I'm moving tab. It doesn't matter. I'm just gonna put everything in this group. I don't know what this stuff is. And then we can just ignore that. It's just extra noise. Oh, what is this? Oh yeah, I remember thinking whatever this is looks quite cool, but I don't know what it is, so I'll take a look at it later. Um, 13. Solid A and solid B are similar. Oh yes, this was the volume scale factor, and I think it's the one where I reckon we were meant to use fractions. Yep, that's what we got. I remember that. Yeah. Right. 14 is 17, so it was indeed 9 plus 8. We got that one right. Oh yeah, this was the one where I wasn't really sure. I think the gradient we got was 25. Ah, bang on 25. Come on, lads. Okay, I don't even need to be able to answer the question properly. It looks like I don't even need a pen. I'm so good. So I think we only got like 1 or 2 questions wrong so far. We're destroying this test so far. We're getting like 90%, 95%. Alright. Yes, so this was the one where we were trying to figure out the population of the species. So we figured out that it was going down by 6 over 8, which is 3 over 4. So I don't know what we did. I'm not sure for this one. The answer was 4.5. I think we got that one right, to be honest. Yeah, I think it's just
6 over 8, that's 3 over 4 times 6. 3 over 4 times 6 is 18 over 4, which is 9 over 2, and then 4.5. Yeah, that's definitely what we got. Yeah. And it was 4.5 million. So then Louise, I said Louise was right because it increases by 5%. Yes, okay, that's on there. Perfect. I think 2 of my examples were on there. Assume I can't get an extra mark for that, but you know. 17. Yes, it's always the 1 mark like explanation questions that throw me off, even though they're only 1 mark. They're always weird. I don't know. Just skip it if you don't get it and it's 1 mark, or if it's really hard and it's 2 or 3, you know. Like, you can always come back to it if you have time at the end. And the questions, if I remember rightly, there are normally like questions over here that I don't normally get to on the tests, so you might just not have to worry about them anyway. Okay, so this is the quadratic one. Yeah, that's what we got. And then this is, I think, this is the one where I was... Ah, okay. Ah. Yeah, this is the one that I was being really, like, pedantic about and trying to figure out based on the maths that was going on. I remember that. Yep. Right, so what we were meant to do is combine it into one statement, because x is the same in both of them. So we weren't having an or because x isn't changing. Really? Well, no, x is changing, but we're not looking for one of them being 0 and the other one 1. We're looking for one of them being negative. So the lowest, so x couldn't be this or it would be 0. And x couldn't be this because it would also be 0. But what I didn't notice is this number is, I think, a lower bound, and this one's an upper bound, or something like that. So, wait, is that the right word? Yeah, I think that's the right word, because this is the highest one x can be, and this is the lowest. So x is actually just in the middle with 2 of these. Would it have accepted my answer? Okay. I think that I might have used the same symbol for this one, so I might have lost like 1 mark on that. Okay, question 18. Right, I now have the answer for that, because question 17 was all I got up to. I did not notice that. Okay, alright. Spinner A and spinner B are spun once. Probability that spinner A lands on red is 1/4. The probability that both spinner A and spinner B land on red is 1/24. Work out the probability that one spinner lands on red and the other spinner does not land on red. So for a start, I'm sure you know your times tables. 24 divided by 4 is 6. So there's a 1 in 6 chance that spinner B lands on red. We don't need to worry about any other colours because it doesn't mention them. So if we... What? Oh, that was a highlight, Jewel. My bad. So we just... This is called a probability tree, I think. Probability diagram. And it's what we're going to want to use. It's often the answer that they like. So this top one is spinner A, this bottom one is spinner B. I don't know if I need to even write that. I mean, write it on the test, but because this pen has a cooldown for some reason. I don't know if that's a good idea. Oh wait, they're each spun once. Wait, no. Ah, okay, okay. I don't think we're looking for a probability tree. Oh, oh, okay. Right, yeah, okay. So what I've just noticed is these events are not mutually exclusive, right? Because these are different spinners. These aren't just different colors on the same spinner. These are different spinners entirely. Oh, I probably didn't need to do that. That might mess something up later. Go away. Go away. There we go. I think it's gone. So no, we don't need a probability tree. So there's a 1 in 4 chance that spinner A lands on red, and a 1 in 6 chance that spinner B lands on red. So the chance that spinner B does not land on red is 5/6, and the probability that spinner A lands on red is 1/4. Yeah, no, actually we do need a thing. We do need a tree. Okay, but we're going to do it slightly differently to how I thought we were going to do it. So this first one is... Why have I drawn it so wonky? Or maybe I did know it, and I just didn't realise it at the time for some reason. I don't know. But, so this is 1/4. This is 3/4 for spinner A. Because for some reason I thought we were going to do one of the ones where you were spinning it twice, but it's not the same spinner, so it doesn't make any sense. Then this is 1/6. This is 5/6. This is 1/6, and we don't really need the other one, to be honest. It's just a waste of text. So, if we look at this, right, this is the chance of this spinning. So this lands on red, this lands on red, right? But then this lands on red, and this is not landing on red. So we multiply these two together, and then add it to multiplying these two together, because this one doesn't, and this one does on this one, right? We don't actually need the last one, because we don't need the probability that they both don't. So I'm just gonna not waste my time on that. 1/4 times 5/6. To be honest, I've never been that good at these. I tend to just kind of guess what the method is. I think you just times the numbers on both the layers together, so it would be 5/24. I think that's how you do it. I don't know. I mean, I'll check immediately after. I'll do the mark scheme on every one. Oh wait, no, we already know the answer. I forgot. I looked by accident. So this is probably equal to 3. Let's see. 3/4 times 1/6 is 3/24. Right, yeah, then you add them together, it's 8/24, and then 8/24 equals 1/3. So it's 1/3. Yippee! There we go, we have the answer now. Because that times that, and that times that. That's the probability. Let's see. Well, I know we're right because I already saw the answer by accident earlier. Oh, I suck at this. Okay. If you get this on the test, good luck, I guess. I can't really. I just normally guess for these ones, for the graph of sine. To be honest, just my sine, cosine, and tan on their own is not great, to be honest.
But okay, okay. So, but I think I can answer some of this. I can try and answer it and then find out what the right answer is. So we want to find the solutions of sine over x equals 0.3. So this is actually something I can do with no knowledge of sine. For this bit at the end just means on the graph, right? Because we're not showing any more of the graph, and this is minus 180 to 180. And then sine of x equals 0.3. So the y equals sine of x, so y equals 0.3, which is around here. And then we just have to figure out what this... So since y equals 0.3 equals here, we can try and draw a straight line. Yes, there we go. We can figure out this one is it's made up of 3/30s, and then this is half 30, I think. Yeah, so this is 15, and then this is 180 minus 15, which is 165. Okay, so the answer to this question is 15 and 165, right? I mean, I don't know the graphs off by heart very well. It's kind of what I meant, but because the diagram's just drawn here, I don't really need to be honest. Oh, okay. So this one here is functions, right? So this is based on the idea that when you have y equals f x, when you add something inside the brackets, it goes left, and when you subtract it, it goes right. So they're adding 20, so the thing would actually move this way 20 instead of this way. It's kind of counterintuitive, but you just got to learn it. So that sine x plus 20 equals 0. Wouldn't that just be 20? No. Okay. Wait, so we're looking for a point on this graph where so x is this part, right? And then when you, let's say we're at like 20 here. I don't know where 20 is actually. I think 20 is like here, but I don't know. So if we have sine x plus 20, then I think that just means it shifts left. So it equals 0. Yeah. I think this one is just minus... No, I think this one is just 20. Oh, I didn't really fully explain this, did I? Yeah, so adding some... I mean, you might have seen this before, but I think it's sometimes shown as x plus a. Here it's x plus 20 though. Yeah, it's going left 20. So 20? Wait. No, it must be... No, it must be minus 20, right? Look at this. X plus 20. Well, if we had 20 plus 20, then that's 40. So that's a 40 shift right, but that's a 40 shift to the left, but this is just an equation. It needs to equal 0, right?
So minus 20 plus 20 equals 0. Sine of 0 is 0. So it's just minus 20. Right, we don't actually need our function knowledge. We just need to be able to solve an equation, which I just didn't expect it to be have a simple answer like that. And we're about to see if it did. So, question 18. Wait, no, wrong question. Question 19. 18 and 162. What? I got 15 and 100. Okay, so apparently the 3 boxes is actually 18, not 15. I must have just done some maths wrong. Let me check that again. Oh yeah, no, that's not halfway. That's divided into 5. Right, yeah. Okay, I know what we've done wrong. So that's 30, 30, 30, but then 30 is actually split into 5. Not 6. So it would be 30 divided by 5 is 6. Then, so each point is 6, 6, 12, 18. Yep. Then this would be 100. 180 minus 18, which is 162. So yeah, it should have been 18 and 162. That one's not right. So I'm just going to change that. I'm allowed to cheat and change my answer. I mean, because I drew the line though, I'd still get a method mark, right? So that's important to do. Draw the line and then mark down the solutions. Okay, I think this one's a minus 20. I don't really know. It's a bit of an odd question. Minus 20 or 160. Okay. But we only needed one value of x, so we would have got the mark for minus 20. 160 is probably just a random one over here. Yeah. Okay, so 160 here. Minus 160 plus 20. It's 180. Wait, no, I don't know. And 180 here is basically 0 because no, I don't know why it's 160. It doesn't matter. You don't need 160. You only need minus 20. So I'm just not going to bother thinking about how it's that. Find the size of angle ABC. Do we need absync? Oh, I should probably explain what absync is first. So, oh no, we don't need absync. This one's the sine rule. Okay, I'm just going to very quickly say what absync is, because absync is literally just is just a word I use to remember the equation. Half AB sine C. I just think of it as a word, because it looks like it says half absync in letters. So that's just how I remember the method, to be honest. That's just how I remember like how it's spelled and all that. But no, we're looking for the. Wait, no, this can't be the sine rule because we don't have an angle to begin with. Oh, that's weird. And we're not given the area either. So how are we meant to do that? Well, I mean, I can tell there must be an answer. It sounds obvious then. But, no, because we've got side, which is proof of congruence. So that means we do... Basically, maths does know the angles. There is a number that the angles can be. So I don't know how you find it from just the sides, though. So if we did absync, we'd need an area for it to equal, and we just don't have that. And we have no explanation of the angles. We've got a surd there, which is kind of random, but okay. we're meant to use trigonometry. Right. No, we're not. No, we're not. Hang on, we can't use trigonometry. It's not a right angle triangle. Does trigonometry only apply with right angle triangle? Yeah, it does. Oh, okay, we can't use trigonometry. Oh. I mean, yippee. I mean, that's... No, it's kind of bad because I don't know the answer now, but it's kind of saving me from trigonometry. Let's see. Wait, not trigonometry. Anything with a triangle is trigonometry. No. I mean like, SOHCAHTOA, all that. Never mind. But okay, I don't really know how to just go about this in general at all. I'm just gonna pause and figure it out. I just accidentally ended the last recording. Okay, so I think what I'm gonna do is I'm just gonna tiptoe onto this thing called the mark scheme right here. I'm just gonna look at the method. I'm not even gonna. Just gonna see it's the cosine rule. What is? What? Wait, what? Oh, the cosine rule. That's not absync, because that's absine C. Oh, isn't there one that's like A plus B plus C equals cos of thing? Or is this the one where it's thing over thing, thing over thing, is thing over thing? I don't know. What is the cosine rule? Okay, I'm gonna look this up. Rare maths law. Why do they have to label it gamma? It's such a stupid symbol. So C square root of A squared plus B squared minus 2 abcos. I feel like there's another way of showing this. I'm sure there's another way of showing this formula. Oh, right, okay. Yeah, I remember this now. So the way I thought of this was A squared equals B squared plus C squared minus 2 because A. Right, I forgot about... I never really gave this one a name. I just kind of thought of it as the 2 minus 2 because A. Right. Yeah. Okay. Oh, this one's slightly clearer. I'll copy paste this one in. Okay, so I just forgot this formula. I'm gonna make a note of that somewhere. I'm trying to remember it. That cosine rule. Just did not know it was a thing. Totally forgot about it. But anyway. Oh, that should be squared. I mean, this is close enough. Right, so we're looking for the angle ABC, right? So since alpha, I don't know, I'm just gonna call that X, I guess. So this angle is what we're trying to find, is X, right? I don't know why it was labeled alpha, that was weird. And then it was just gamma on the other one, I don't know. No consistency. What's going on, maths? So X is that. We're trying to find that. Okay. So let's just work through everything else like in a normal formula. We need to find A squared. So I don't think that A and B are specific ones. Side A, side B, and then angle opposite C. Right, so x is the angle opposite c, so that makes this one c, because we're trying to find this angle. But then a can be 10 squared, I guess, and b can be 5. Well, no, they're squared because they're squared in formula. A is 10, b is 5, right? Then plus, I forgot about that, bullying me. Plus 5 surd. I've just thought I could show surds like that because it looks slightly more. It looks slightly more like a thingy. Looks slightly more like a square root symbol. 5 square root 7 minus 2 times. Do we need brackets actually? No, we don't. 2 times 5 times 5 surd. Shut up. Actually, that looked really cool. I'm gonna take a look at that later, but not right now because I'm doing maths. I'm doing maths. Very important stuff. Very important stuff. Cos x. Okay. So now let's just do some maths. 100 equals 25 plus. Oh wait, I didn't put the squared symbol on that. Plus, how do you square surd? Isn't it just like 5 times 7? Yeah, I think it's just 5 times 7. Because surd squared is just the number inside the surd. So 5 times 7 is 35. Oh, I remember this time. I remember the button, and it's in minus anyway, so it doesn't freaking matter. Minus 10. 10, and then 10 times 5. Surd 7 is just 50 surd 7. Times cos x. Okay, this still isn't looking too like non-calculator friendly. For a start, how do I figure out cos of x on a non-calculator paper? What? Oh wait, no, I'm an idiot. This is literally what we're finding by this equation. Ignore that. So these are both positive, so we can actually switch them over to minus 25, and then also minusing 35. Don't minus 35 from 25 though, because that's not how it works. So that'd be 75, and then minus 35 is 40. 40 equals minus 50 surd 7 times cos x. So what we're going to want to do is we're going to want to divide this by that so we can get rid of it. But that also means we've got 40 divided by. Wait, do we multiply the other side or divide it? You know, I think we divide it. Yeah. Divide it by minus 50 surd 7 equals cos x. So then I have to make that cos minus 1 I should probably thingy that. (40 over minus 50 third 7 equals x. But I can't actually figure out x from this, because I think that the way I'm meant to do it is just knowing the like different cos values and figuring it out from there, but I don't. So this is the closest I can get, but I'll probably get like nearly full marks for that. Let's see. Question 20. So for using the cosine rule, we get a mark. For process to find what? Cos B? We're trying to find angle ABC. Oh yeah, I guess because it's ABC, they call it B, even though it's opposite C, so I called it C. But yeah, no. Oh no, I called it X. No. Yeah, so their cos B is actually cos X on mine. So that, I mean, that's not really the formula we used. Yeah, okay, I think this is what we needed that we didn't have. Oh, so I think I only got 2 marks for that, to be honest, just because I don't know the actual values, the trigonometry. Hopefully you can figure that out if you want. If you want to figure that out, you're probably good at maths, so you know. Look up a different tutorial. I don't know. I don't know how to do that, so I just kind of skip over it normally. I'm gonna learn that at some point, but not right now. On the grid, draw the graph of x squared plus y squared equals 169. Okay, I actually could figure this one out instantly. So before, I think I had one which was x squared plus y squared is 25. I now know that that is this formula. What the formula for a circle looks like, and this number on the end is always squared, but you square root it to find the radius of the circle, and this square root of this is 13. So what we'd want to do is we'd have 13 is kind of there, and there, and there, and there, and then we join this up in a lovely little circle. I don't have a compass. That doesn't look lovely at all. That is the worst circle. Ah, there we go. This is beautiful. Okay, if it tells us to do anything to do with the diagram, we're kind of cooked. Ah! What the frick? How do we... what? Oh, no, I get it now. Okay, so this is also y equals 3 over 2x. So, and 3 over 2 means that the rise is 3 and the run is 2, right? So first this is actually a separate line we need to plot. So this is roughly where 3 is at 2. So the line has to kind of go like that. And what you'd do is you'd use your much better graphs to figure out where this point is, where they touch. And you want one on the other side too. Right, so the best estimate I can really give is minus 8 minus 10 and 6 10, which should probably be, so it's probably about like 7 10 and minus 7 minus 10. Let's see. Okay, there are really specific values. I don't have a compass to draw a circle with, obviously, but they got
7.2 and 10 8.8 minus 7 to minus 10.8. So yeah, I'm gonna just say full marks. Just gonna draw a smiley face, I guess. Look at that, we did it. We coped. Yay. He's got a really big smile, he's really happy. That's just to show we got the answer right. I mean, there was no reason to add that. So, you don't need to know how to draw a smiley face for maths, just to clarify, you know. Okay, I think this is the last question. Yeah, I'm pretty sure it only goes up to 22. Oh, okay. What the frick is a geometric sequence? Oh, what the frick? For some reason, we just didn't do a lesson on geometric sequences. We did like the quadratic ones, and then we just stopped. So I don't know what this means. I'm guessing it's just something like n equals a plus square root of b. So I think I can work this out just like it's a normal one. Okay. No, it's only got the second and third terms. So I'm just going to have to assume that it's not changing at all. So it's adding... So if we look at the actual common differences, right? Okay, it's 4 marks. Okay. So the actual common difference here, it's... Wait, let me try and... It's jumping from 3... Stop doing that. 3 plus 2... third. It's going... And we're gonna figure out what's being added to get 13 plus 9 squared. Just gotta figure out what's being added. So it's 10 plus 7. Wait, did I say squared? I mean square root 2. Right, so that's what it's adding every time. Okay. To be honest, I just write this. I don't know what a geometric sequence is. I can't honestly really answer this. I know that this is the amount it's going up by every time. But that's all I really know. Because I don't know where the n goes in this. 3 plus square root of 2. Oh, that's not what we got. Oh my god, that looks horrendous. Yeah, no, I just wouldn't get that on the assessment. To be honest, like, I'm gonna I guess in the future I'm just gonna practice the hell out of geometric sequences when I'm revising, and hopefully get that right next time. But yeah, I think that's the end of the video. Pretty sure I got a grade 9. Write in the comments what you think. Although I did give myself infinite time, so you know, that's kind of cheating. But I think I did a pretty good job. And yeah, that's it for this maths video.